Alright guys, here's an example on one variable modeling. So I'm going to create a video on it so you guys can have an example to use to study for your exams and stuff like that, okay? So here's the example. I recommend that you always use a chart to organize your thought process so that way you always remember what to do, or you're always going to be able to see how the whole problems work out together, okay? So here's the example. Here's example 3. It says Hannah has two more than twice as many photo albums as Amy. If Amy buys 10 more albums, she and Hannah will have the same number of albums. And so it looks very complicated here, but you start breaking it down piece by piece by asking who are we talking about. You can clearly see that we're talking about Hannah and Amy. So here under who, I will put H for Hannah, I put A for Amy, right? Then, right after that, I'm going to say, okay, we have an original set number of albums, so let's look at it and see what is it talking about the type of albums that it has. So then it says, Hannah has two more than, so in math, more than really means addition, right? So more than something you add. Twice. In math, when you say twice, that means multiplication. So it says Hannah has two more than twice as many albums as Amy. So that means under Hannah here, I'm going to put two more than twice as much as Amy. Right? So now that tells me, okay, that's two more than twice as much as Amy. That means I don't know what kind of album, how many albums Amy has. So I'm going to call it something unknown. So I'm going to call it A. So that's representing Amy's album. Okay. Now that we completed our original set of question, we then go and say, okay, what kind of album do they have now? So now it says, if Amy buys 10 more albums, that means Amy originally has 8 albums, and now she's buying 10 more albums. So now 10 more means addition. That means Amy now has A, which is what she started with, plus 10 more. Then it stops there. Then it says, well, do we know how many albums Anna has? We don't. So then since Anna hasn't bought any more albums, that means Anna stays the same. Okay? And then now we're ready for the question. Okay? The question and the statement that will help you identify which functions are equal to what. And they're usually right at towards the end, okay, of the whole passage. So it says, she and Anna will have the same number of albums now. See that? This is part of the now. So that means this is all we're going to focus on. And it says, she and Anna now will have the same album. So in other words, the same number of albums. That's just another way of saying they have equivalent number of albums. That means they're equal to each other. So now they're equal to each other. And that's your sentence. So that tells me that Hannah 2 plus 2a has to equal to a plus 10. You see that? So we're going to say, oh, okay. So now the question they ask me is, how many albums does each person have? So they want to know, how many albums does each person have now? Now. Right here. Not original. Now. Right? So we're going to say, okay, if they equal each other, so let's try to solve. So if I solve them, let's say, well, let's combine like terms. So I'm going to minus a to both sides. So when I do that, combine the a term. And so I get 2 plus 1a is equal to 10. Then I'm going to say, okay, let's minus 2 from both sides to combine the number of albums. And when I do that, I'm going to get a is equal to 8. So it tells me that Amy originally has 8 albums. Okay? But now I want to know how many albums did each person have. And so I'm going to say, well, if A is 8, then if I plug an 8 here, what's 8 plus 10? Well, of course, that's going to be 18. If I plug 8 here, what's 2 times 8? 16. 16 plus 2 is 18. So that tells me it checks out that when A is 8 albums, both of them equals 18. So now I can interpret my answer. So my answer is, okay, now Amy and album will have, each will have 8 albums. And that's the interpretation of my answer in the context of this problem. Okay? Let's do another example here. Let's go back down here. Let's do one more example. Here we go. Here's example 4. Here's what it says. Caitlin did 6 and 7 of the problems on her math quiz correctly, and only 4 incorrect problems. That's the statement. So then I can say, okay, who type of problem? We're talking about Caitlin. That's only her, only one person. And then she have 2 type of problems. She have the correct ones, she have the incorrect ones, and she have the total on her quiz. Now, do we know how many problems she did? We don't. So we're going to put X, something we don't know. Okay. Then I go back to the sentence and I says, Caitlin did 7 out of 7 of her problems correctly. So here's 6 out of 7 correctly. So how do I know how many is incorrect? Well, I know the total is 7 out of 7, right? And she did 6 out of 7 correct. So if I take 7 out of 7 minus 6 out of 7, I will get 1 out of 7 incorrect. So 6 out of 7 correct, 1 out of 7 incorrect. Then it also says, of the one that's incorrect, she did 4. Of the one that she did 4 problems incorrectly. So the number of problems she did incorrectly will be 4. So then whatever's left must be what she did correct. So if I take the total number and I subtract what she did incorrectly, then that means what she did correct is X minus 4. Okay. Now it says she did all the problems. How many were there? So I want to know how many problems were there inside her quiz. X. That's what I wanted to know. Okay. So now I'm going to go back and say, what is it about this relationship that they talk about? And here's the key word up here. Notice there? It says, Caitlin did 6, 7 of the problems on her math quiz correctly. That means that 6 out of 7 of means multiply the number of problems, which we don't know, so we call that X. So this means she did 6 out of 7 of X, and that has to equal to the correct number. So where's the correct number? The correct number is X minus 4. And so now you have your equation, and you can solve. So the easiest way would be, oh, I don't like fractions. I'm going to multiply by the common denominator. So if I look at all my denominators, the common denominator among 7, 1, and 7 is 7. Right? So when I do that, I'm going to distribute 7 through everything. And so I'm going to get 7 times 6 is 42. 42 divided by 7 is 6x equals 7 times x is 7x. And then 7 times negative 4 is negative 28. Okay, let's combine like terms. So I'm going to take the 6x and 7x, combine together. So to do that, I'm going to say, okay, let's subtract 7x from both sides. Take the inverse property of positive 7x, which is negative 7x. That cancels out. I reduce here. 6x minus 7x give you negative 1x equals negative 28. So this is multiplications. What's the inverse of negative 1 times x? Well, that's divided by negative 1. So divided by negative 1 per both sides, x would be 28. So that tells me that Caitlin actually had 28 questions in her test. 28 minus 4, that means she did 24 correctly. And then she did 4 incorrectly, and it checks out. 24 plus 4 is 28. So that's how you know, okay, I'm doing it right. I'm on the right track. Okay? So now, let's interpret the results. How many were there? There were 28 questions in Caitlin's quiz, where she did 24 correctly and 4 incorrectly. Okay? And that's how you interpret the results. So given these 2 examples, you guys can use it to help you solve other problems. Okay?